a pretty decent crowd already. So let me, I guess, just real quick, like I was telling Jeremy earlier, why I wanted to have him come and do this talk is because I use Async Await all the time in my Xamarin apps. And it works really well for me, and it's great. I love it. But there's also, I don't understand it probably nearly as well as I should. And there's some gotchas I run into sometimes where I kind of realize that there's more going on under the hood than I really understand. And I suspect that probably most of us are in a similar boat. So I thought it'd be really good to have someone come in and really kind of unravel the innards of what's going on and help us understand how it's actually working and what what the best practices are and what the worst practices that we may be doing are. And so that's kind of why I asked Jeremy to come do this presentation. And take it away, Jeremy. Thanks.
Yeah, thanks for having me. I appreciate it. And actually, that's the reason I do this talk, because, kind of some history on this is I've been doing .NET since 2005, so it's been a while now. And when Task first came out and the Task Parallel library, I kind of looked at it and I said, you know what, I can tell this is important, but I don't know why. And when I look at it, it's really complex. There's kind of a lot of stuff in here and I don't know what I really need to do to get started. So of course it goes to the bottom of the list of things to learn. And then, 2 more years go by and .NET 4.5 comes out and it has async await built in to the language, right? And now I'm kind of like, this still looks important. And I see that it's a wrapper around task. So maybe I should learn this, but oh, this looks really complex. And then I was one of those brave people who, when Windows 8 came out, I said, well, let's do some Windows 8 apps to see what this is like. And when you did just the file new project on a Windows 8 app, you basically got something that had async await sprinkled throughout the entire template. And that was because of the app model. Basically, they said, if you block a thread for more than, I don't even remember what it was like 4 seconds, we're going to kill your application automatically because we're not going to let your apps hang. So the idea of you can't let your app hang, you have to get onto another thread so that you can do stuff in the background, keep your application responsive, now became kind of a critical part of how we have to do programming. Now, we all know how well Windows 8 went as far as applications were concerned, but we did end up with async and await along the way. So basically, the plan for tonight is to understand it better. So what Jason described is exactly what I'm going to talk about. So async and await are out there. We're going to look at what's behind them, which is task. And we're going to basically call an asynchronous method, get some data back from it, handle exceptions, and deal with cancellation. Those are kind of the 4 things we're going to look at tonight. And along the way, we're going to kind of see some of the gotchas, some of the things we want to do, some of the things we want to avoid. And that's really the whole idea of the evening. So if you want these slides and code samples, you can go out to my website, jeremybytes.com, and you'll find a link to this talk along with a bunch of resources out there. So I might be showing those later on, depending on what kind of questions we have. There's also kind of a lot of supplementary articles that I've written along the way. And then feel free to follow me on Twitter if you'd like. I'm Jeremy Bytes on Twitter. So with that, let's go ahead and get started here. And I'm just going to talk a little bit of history because asynchronous programming has never been an easy thing. So I never did manual threading myself because I had friends and coworkers who did manual threading and got into all kinds of problems with it. So I tried to avoid it as much as possible. But throughout the years, .NET, the people who are building the language and the compiler said, let's do some things to kind of make things easier to do async and hopefully kind of keep you out of trouble. So we went through things like the asynchronous programming model, or APM, and the event asynchronous pattern, or EAP, and the task asynchronous pattern, or TAP, and that's actually where we live today. And kind of looking at these really quickly, the asynchronous programming model, this was a method-based thing where you basically had a pair of methods. You had a begin something something and an end something something. And the begin method would return you an iAsync result object that you had to pass to the as a parameter to the end method. And I always had to look up how to do this. So I could never remember how to do it. I'd always have to look it up. And then there were some problems because how do you deal with errors in this environment? And it was pretty complex if you wanted to do anything more than just kind of the trivial. And even the trivial stuff, it's like, well, I want to check for error messages. And that was a little bit difficult. So they said, okay, well, let's come up with another pattern, and we're going to call this the event asynchronous pattern. And this is event-based. And the good thing about this is event handlers are kind of the second thing you learn if you're learning C#. The first thing you learn is, console.writeLine hello world. And then the second thing you learn is button.click, right? So if you can hook up a button click event handler, you can do asynchronous programming. That's really what the idea behind this was. And so basically, there'd be a method such as get data async, and you would call that, and it would kick off this asynchronous process. And then you had an event handler or an event, and you would hook up a handler to that, and that event would fire once that asynchronous process was done. And so if you needed any kind of payload back from this asynchronous method, that would be in the event args. So the event args would have generally a custom event args that would have your data in it. So advantage, really easy to use. But again, what happens if something goes wrong? Well, basically your event will never fire, and you're going to be left waiting for something indefinitely. So from that standpoint, not real great. So then we ended up with task and the task asynchronous pattern. And this is actually where we live today. And when we talk about this, it's task-based, and hopefully that's apparent from the name. And generally what we have is a method that returns a task or a task of T. Now, if we have a task of T, the T, that generic type, represents a payload coming back. So if we're expecting data coming back from our asynchronous method, then that would be the type specified for that. Otherwise, you can have a task without a generic type, and that would say, well, this doesn't have any data it's returning to you, but you still have access to the task, so you can check to see when it's done, you can see if any errors happened, things like that. So having the task is still useful even if you're not getting an actual payload back. Now, when we talk about what a task is, this is something that represents a concurrent operation. The interesting thing is this may or may not happen on a separate thread. So we like to think about, asynchronous as multi-threaded programming. So we're getting off our current thread and we're spinning up some other thread or using something from the thread pool, and that's where this other thing is going to run. Now, in some cases, the asynchronous process doesn't require any thread resources, so it might not consume any. In the example that I'm going to be showing tonight, we will be using a separate thread, and the example specifically set up that way so we can kind of see when things are asynchronous and when they're not. Now, the thing that's really cool about task is it's extremely powerful. So tasks can be chained and combined in different ways. So I could have a task, and when it's done, another task kicks off, and when that one's done, another task kicks off. Or I could have a task that kicks off. When it's done, 5 separate child tasks all kick off at the same time. And then when all of those are done, we can do something at the end. So there's a lot of different ways that we can, set up these kind of workflows that are all asynchronous. And it's extremely powerful. Now, unfortunately, it's also extremely complex. And that's kind of where we run into the problem of task. So I'm going to flip over to code now because I'm not a big fan of slides. I like code. And like I said, these code samples are available. There's a link on my website. And these are all on GitHub. So, and I'm not doing Xamarin programming tonight because I figured if I fumbled through Xamarin, that would be really embarrassing. but my application is a WPF application, so it does use XAML at least. And it will kind of show us some of the things in a desktop world that we need to be concerned about. But the asynchronous processes are also really important on the web servers as well, because if we end up blocking threads on our web servers, we basically end up blocking incoming request threads, and we can inadvertently limit how many people can connect to our servers at any one time. So, wow, I'm babbling. Let me show you this application. And feel free to slow me down if I'm talking way too fast. And if you have any questions, please feel free to put them in the chat or unmute, because otherwise it's just me talking to my camera, which is right here. So I would love some interaction if you have questions. So here's my amazing application. And I have 3 buttons. I have one that's fetch data with task, another one fetch data with await, and a cancel button. These currently do not do anything. And then on the right, I have a list box that will hold our data. In the project, let's see, there are, whoa, okay. There are 4 projects in the project that we have. We're actually only going to be looking at 2 files tonight, so it won't be too confusing. The people.service project is a web API service, and this is where we're going to be retrieving the data, and that is the data we'll put into the list box. The using task.library project, this is a library project that contains the method we're going to call, and that's an asynchronous method in that library. And then the bottom one, task.ui, that's our WPF application, and that's where we're going to be calling the asynchronous method. And then the shared project has like shared data types, which are shared between the service and the library and the UI. So let's take a look at, let's see, the library. And this is the method that we're going to call. So on line 23, there's a getAsync method. Now, generally, asynchronous methods end with the letters A, S, Y, and C. That's a convention. That's not something that's required. And I've heard debates both ways about whether that's a good convention or not. I go ahead and follow it because it's easier than fighting with people. And then, like I mentioned, the asynchronous method returns a task. And in this case, it returns a task of T. Our T happens to be a list of person. So what this is telling me is I'm going to get a task back, and the task has a payload, which is of type list of person. So it's basically a promise. At some point in the future, I will have a list of person objects. And we're not going to spend too much time looking at the code that's actually in this file. This is using an HTTP client to make a call out to that web service. And but the one thing I want to point out is here on line 25, where I have a task.delay 3000. Now, in order to show that things are happening asynchronously, I put an artificial delay in here, because otherwise calling a service on my local machine, it would happen close to instantaneously, at least from a user standpoint. So we wouldn't really be able to see that it was truly asynchronous and that we were getting what we wanted. So I put an artificial delay in here. Now, if you're not familiar with task.delay, it's very similar to thread.sleep, but you don't have to feel quite as dirty when you use it. So there might be times where, for whatever reason, our application's not working, but if I pause for 2 seconds, then it works. And so it's tempting to put a thread.sleep in there and basically say, okay, go to sleep for 2 seconds. And when you're done, I'm pretty sure the next thing that's in this method is going to work. Now, the problem with thread.sleep is it's a blocking operation, and it will block the current thread. It's basically a while loop. So during those 2 seconds, your computer's just going bzzz in a while loop while it's waiting for the time to elapse. Task.delay has the same effect when we await it. So here we're actually awaiting the task.delay. So this will pause for 3000 milliseconds or 3 seconds, but it does it without consuming any thread resources, which is really cool. So that means I don't have to feel as bad when I use it. If I am putting this into an application on purpose, there's probably something else that's going on with the application. So you should feel a little bad if you put this into your application, but definitely you can feel free to feel less bad than when you use thread.sleep. And then the rest of this method is using the HTTP client to call out to the service. And before I do anything else, I'm going to start the service so I do not forget that. Everything I'm doing tonight is .NET Core 3.1. And I have this power commands thing installed on my in my Visual Studio. And this has a really cool right-click menu, which has an open command prompt. And what this will do is it will open a command prompt to the location that I just right-clicked on. So in this case, since I clicked on the People Service project, it opened it right to that folder. And what that means is I can just type .NET Run, and it will fire up the service, and I don't have to go looking for it. It's just there. So if you're interested in that, Power Commands is available in the Visual Studio Marketplace, and it's free. So I like that, because the old way I used to do was I would right click on it and say, okay, open in File Explorer. And then it would open on another monitor. And then I would come in and say, okay, open PowerShell here. And that's kind of slow. So that power command is awesome. So our service is running. So now I'm going to go to the WPF application. And in this case, I just have code in the code behind of my main window class. I'm using code behind so that we don't get buried in architecture or MVVM or MVU or whatever, whatever UI pattern you want to use. I want to focus on using task and await. So I'm just going to put things in the code behind, but this isn't normally where I put them. Now my code behind is fairly empty at this point. I have a button for my fetch with, an event handler, I should say, for my task button, one for my await button, and one for my cancel button. And then there's a clear list box method, which clears out the items in the list box. Okay, so I'm going to pretend that I don't necessarily have access to this code, but maybe I have access to the library. And I'm going to let Visual Studio help me figure out how to use this get async method that I'm looking for. So first I'm going to create a class level variable or a class level field to hold this person reader object. And we'll just call this reader. Oop. And we'll just new that up. And then down in my fetch with task button, I'm just going to start by saying var result equals reader.getAsync. Okay, so sometimes I don't know the types that are coming back from libraries. And so I let Visual Studio help me with this. var is strongly typed. It's just a developer shortcut in this case. And so if I hover over this, it tells me what type it is that's coming back. And so on the first line, we can see it's a task of tResult. And then down at the bottom, it says tResult is a list of person. So this is a task of list of person. Not a surprise, since that's what we saw when we looked at the code. But if you have to figure this out on your own, this is such an easy way of doing it. I remember using this method. It was a library that I was using that was returning some weird event, and I couldn't figure out the type I needed to hook up. And yeah, so that's awesome. And then we'll change result to person task, since that more closely matches what we have. Okay, so what we've done here is we've kicked off that asynchronous method, and we have a task back. Okay, great. Now what do we do with it? Now, something that's really tempting is to look at the task and say, okay, what properties do I have? Well, there's a result property on the task, and the result property is actually a list of person. Okay, so it's really tempting to say, you know what, I'm just going to for each over this. So for each person in person task.result, person list box.items.add person. So I'm just going to loop through the items and stick them in the list box. And this sounds really great until I actually run the code. Because when I run the application, and let's see what monitor it pops up on. Oh, the right one. And click the button and wait our 3 seconds. There's going to be a lot of waiting for 3 seconds here. Yeah, so here's a problem. I just created a deadlock. This application will never come back. So yeah, so I can't move my application. I can't interact with it. I can't do anything with it. In fact, the best I can do is go to Task Manager and say, let's get rid of this. So what I just did was create a deadlock. So using task.result here is not good. And the reason for that is because if the result property is not populated yet when I try to access it, it's going to wait for it to be populated. So what I've just done is I've killed the concurrency in my application. So in this case, what's happening is I'm on a UI thread at this point. And so the UI thread is actually waiting for the result property to be populated. So my thread is stopped at this point. Now, unfortunately, on the other end, the task is, it's going through its process and populating the result property, but then it's kind of it's waiting for the UI thread to say it's okay to give the data back. So we actually cause a deadlock. So that's not good. Okay, great. Okay, so we don't want to use task.result here to get the data back. Okay, so how do we get data out of this task? Well, what we're going to do is set up what's known as a continuation. And what the continuation does is it says, okay, once this asynchronous task is complete, I would like you to continue by doing something else. And this is one of the things that really threw me when I was first trying to use task. Because if I say person task dot continue with, and look at what we have, the first thing to notice is that there are 40 overloads on this method. 40 overloads. And that was kind of where I said, you know what? I don't think I have time for this right now. I should come back to this another time, because 40 overloads is a lot. I might have come back to it later and said, okay, well, generally the thing that's used the most is put in slot number 1. So let's take a look at the parameter for this. Well, if I look for the parameter for this, it wants an action of task of list of person. Wow. Yeah, nested generics. Do you like nested generics? Because I've got nested generics for you. So this an action of task of list of person. What does that even mean? Well, an action is a built-in delegate type in the .NET world. And it specifies, in this case, a method that takes one parameter and returns void. Now, the parameter type that we're looking at here is what's in the generic type for the action, which is a task of list of person. So what this is saying is I need a method that takes a task of list of person as a parameter and returns void. That's what I need to do to satisfy this. And if you want to learn more about func and action, in the links for this talk, I have another talk about delegates in .NET, and that talks about all kinds of fun stuff with func and action. Okay, so I need something that returns void. We'll call it populate list box, since that's what I'm trying to do. And it needs to take a task of list of person as a parameter, which I'll just call task. So if I have a matching signature, theoretically, I can copy the method name into the continue with, and the red squigglies will go away. Yay, I like that. Okay, so I have a matching signature. Now what? Well, what I'm going to do is task.result. Because why not? Actually, it's okay to use task.result inside of a continuation, because the continuation will not run until after that asynchronous process is done. So in this case, I know result will be populated unless we get an exception or cancellation. So it will be populated with a caveat. So it's safe to use task.result here because I don't have to worry about causing deadlocks or blocking threads. Now, since task.result is a list of person, I'm just going to create a local variable to hold that value so that it's a little bit more readable. I have a better idea of what this type is. And then we'll just for each over this. So for each person in people, person list box.items, items.add person. Okay. So I'm feeling kind of okay about this code. Let's go ahead and run it and see what happens. So again, we'll click our button and we'll wait our 3 seconds. And the 3 seconds seems to get longer as the demo goes on. And we got an exception. So for people who do UI programming and have done multi-threaded programming with a desktop UI, this error looks very familiar. The calling thread cannot access this object because a different thread owns it. And so basically what this is saying is I'm trying to access the list box from not the UI thread. So unfortunately, I don't have enough experience with Xamarin to know, do you have this problem in Xamarin? Anyone?
Absolutely.
Absolutely. Okay, good. So this is entirely relevant. Okay, so the next thing I do is I say, okay, I remember this, okay, because I tried to do my own threading once and it ended badly. But I remember, so you have to marshal back to the UI thread. And so you have to do like a dispatcher.invoke and all this stuff. You know what? I don't have time for that. So there's actually an easier way we can do it when we're using task. Now, if you would like to do the dispatcher.invoke, it will actually work in this scenario. But I would say let the task parallel library do this for you because it's a lot easier. And for this, what we're going to do is we're just going to look at another one of these overloads on continue with. And in fact, I feel like number 8 is a really good one that we should look at. So we'll look at number 8. Hey, look at that. So for overload number 8, in addition to the action of task as a parameter, it also takes a task scheduler as a parameter. Now, the task scheduler is the object that's responsible for managing all of the tasks. So it's basically looking at the tasks that have been created and says, oh, okay, is this one ready to run or is it waiting for something else to complete? Okay, this one's ready to run. What should I do with it? Okay, let me grab a thread from the thread pool and put it on it. It's the thing that's handling all of that. So that's what the task scheduler is responsible for. Now, there is a magical method which is a static method on the task scheduler class, which is from current synchronization context. Now, it should be clear to all of you based on the name exactly what this does. Is it perfectly clear? Yeah, I love how Microsoft names things. So what this is saying from current synchronization context is saying, you know what, for this continuation, I would like you to run this in the same context as where this continue with method is being called. So for example, in this case, I'm being run inside a button click event handler, which is on the UI thread. So when I say from current synchronization context, I'm saying to run this continuation, go back to the UI thread. And that's not the default behavior for task. And so basically what happens is if you don't tell it otherwise, the task scheduler says, oh, okay, I'm done running this get async method. What do I have to do next? Oh, wait, there's a continuation. I'm supposed to run this populate list box method. Where should I run that? Oh, you know what? I've got this thread that I was just using. I'm just going to keep using it. So kind of by default, it keeps running on the same not UI thread that it was using before. So if we want to go back to the UI thread in this case, we specifically have to tell it, hey, you know what? Go back to the current synchronization context to do this. And so now if we do this and run our application and click on the button, data. Oh, that was a really long way to get here. Okay, now the next question is it asynchronous? Now, I will say this is not very impressive over a screen share. It's much more impressive in person because the screen share will be jaggy. But watch this. So I'm going to click on the button, and then I'm going to move the window. Do you see that? Did you see that? My UI was not locked up while that was happening. That is such a big deal. So I am actually showing that this is happening on a separate thread, not the UI thread. And so my UI stays responsive. And this is something that I found so valuable because I did corporate development for many, many years and built line of business applications. And they were mostly desktop applications. And a lot of times what we'd have is like some report that would take forever to run. And so what would happen is the user would click the go button on the report, and then the application would just hang while that was happening, right? And it would go into a not responding state, right? We all love that. And so whenever you get an application that's not responding, you have to make a decision. You say, okay, do I wait and hope that it starts responding at some point in the future? Or should I go to Task Manager and kill this? And one of the worst things you ever have to teach a user is how to go into Task Manager to kill an application. I feel like if I have to teach my user that, then I have failed as an application developer. So by doing something like this and saying, hey, you know what, this long-running process, I'm going to put that somewhere else, not the UI thread. Now the UI stays responsive. Now, there are interesting issues with that because we still need to let the user know, hey, that report that you asked for, it is running. So I actually put up a little clock timer for one of my users, and so they could see the clock ticking, and as long as they saw the clock ticking, they felt sure that it would come back someday. So our code works, and it's asynchronous, but this is not code that you will see in any examples at all online because it's not cool enough, because it doesn't use Lambda expressions. Now, Lambda expressions are another thing that I enjoy. I don't know if enjoy is the right word. I think they're important for people to learn. And that's because 90% of the examples online use Lambda expressions where they could use a separate method. And that's because that's what the cool kids do. So even if you don't use Lambda expressions yourself, you need to learn them so that you can understand the sample code you see online. Now, the way that Lambda expressions are mostly used, at least in my world, I'll say, is as an anonymous delegate. Now, what we have here is known as a named delegate. And it's a delegate because if you remember, our method said, well, I need an action of something. And an action is a built-in delegate type in .NET. So I have a named delegate, and the name happens to be populate list box. Terminology in the delegate world gets pretty bad. And so what I'm going to do is I'm going to take this named delegate and turn it into an anonymous delegate. And I can do that by taking the method body, or I'm sorry, the parameters and the method body. I'm going to highlight those and copy them to my clipboard. And then up here where I'm using this populate list box, instead of doing that, I'm going to type in the delegate keyword and then paste. And what I've just done is inline that code. So I can get rid of this completely separate method. We don't need that anymore. And so what I've done is I've created what's known as an anonymous delegate. And the official definition for an anonymous delegate is a delegate without a name. Yeah, I love documentation. So it's basically inline code. Now I mentioned that a Lambda expression is an anonymous delegate, the way we're going to use it here. And so that kind of implies we should be able to turn this anonymous delegate into a Lambda expression. And that's what I'm going to do. So to do that, I'm going to delete the delegate keyword. And then in between the parameters and the method body, I'm going to add that equals greater than sign, that fat arrow Lambda operator. And now I have a lambda expression. Now I realize this doesn't look like a lambda expression because it is still quite readable. I can understand what it is, but it is a lambda expression. And lambda expressions, because they came out at the same time as LINQ, they were actually added to the language because of LINQ, language integrated query, which is one of the best things ever added to C#. They were designed to be very compact, and so there's a lot of syntactic sugar with lambda expressions. One of those items is known as parameter type inference. Now, I would recommend you write down parameter type inference just because when you say it in front of your boss, you sound really smart. Now, what parameter type inference means is that if the compiler can figure out the type of the parameter for the lambda expression, I do not have to type it in. And so if I hover over task, I can see this is still strongly typed. It knows this is a task of list a person. And how does it know that? Well, if we go back to our method signature, well, I need an action of task of list a person here. And by definition, this is an action that takes one parameter of type task of list a person. So the compiler can figure out from context what this is supposed to be. So I do not need to type it in because of parameter type inference. Now, another thing with lambda expressions is if you only have one parameter, you do not need parentheses around it. And then by convention, a lot of people will use single character parameter names for lambda expressions. I generally don't do that for multi-line bodies. If I have a single line, then I'll often do that, but I won't do that here. And so now that looks a lot more like a lambda expression that we would typically see. But it's the same thing. So this is a method that takes a task of list a person as a parameter, returns void. And then if we run the application, we'll see that this still works the same way. And I know we've known each other for all of 45, 15, what time is it? Wow, okay, 45 minutes. Hopefully you trust me by now. So we'll click the button and we'll see that our data comes up. So this still works the same way. Now, this is kind of a problem with task in general, is that it's not an entry-level tool. So someone who's brand new to C# is going to have difficulties with task. And that's because if we look through this, we see we have nested generics. Okay, so I have to understand nested generics. I have the action, right? Action of task of list a person. So I need to understand delegates really well. I probably need to understand lambda expressions because that's what all the examples are going to be. And then I don't want to even start on this from current synchronization context. Where would I even find that, right? So it's not exactly a beginner level thing. Now, like I mentioned, task is very, very powerful. But it turns out that doing kind of this action right here is what a lot of people have to do 95% of the time. In my world, where I'm basically, writing corporate line of business applications that I did for many years, I'm not doing that anymore, but I spent 11 years writing corporate apps. It would be, okay, I want to kick off this process and get a result back. That's basically what I want to do. And because of that and the complications, when .NET 4.5 came out, our language designers for C# said, let's make this 95% option a lot easier. And that's actually where we got async await from. Now, when we talk about what async await is, it's really a syntactic wrapper around task. Now, I will put a little asterisk next to that because since then, it's been extended a little bit. You can actually await things that aren't tasks, but I'm not going to talk about those this evening. But it's the way we'll use it tonight, and probably the way you're mostly using it, is as a syntactic wrapper around task. And what it does is it basically pauses the current method until the task is done, okay? And then from there, when we do that, we just kind of write code the way we normally would. And so we would expect it to be a blocking operation where we say, oh, well, if I stop here for 3 seconds, that's going to hang the thread because this is, all one thing, but it's not. And that's what's really cool about it because it looks like the normal code we're used to writing. It looks like a blocking operation, but it does not block the current thread. And that's really cool. Now, when we talk about what Async is really just a hint. And hint is probably not a strong enough word, but the async modifier tells the compiler, hey, you know what? Await is going to be used in this special way here. And the primary reason for that is because await was not a reserved word in C#. So you technically could have had something in your code already that was named, quote, await. And so to avoid accidentally breaking code, even though probably not real likely, they said, you know what, we're going to have this async modifier that we can put on a method. And adding async to a method does not magically make it asynchronous. But what it does do is it tells the compiler, if you find the word await inside this block of code, I want you to use it in this special way. So that's really what async is. So let's do the same thing that we just did, which was kick off an asynchronous method, get the data back, put it into our list box. But now let's use await for this. And so we'll just scroll down to our fetch with await button and get started on this. Now, kind of like I did before, I'm going to let Visual Studio help me out because I love using my tools. And so we'll do the same thing I did before. So var result equals reader.getAsync. And then I'll hover over this. And notice that this says that this method is awaitable. Okay, that's cool. That means I can use await with this. So we'll put an await in front of that. And now my compiler is going to get mad at me because it's saying, hey, you need an async modifier here. The await operator on its own isn't going to work. Now, I will give you a little bit of a warning here because it's really tempting to use control dot, because I love control dot, to just say, okay, go ahead and do this. But unfortunately, since I'm in an event handler, if I do either of these options, it's going to break my code. So what this first option is saying is, okay, well, I'm going to add the async modifier, and then I'm going to change it from void to task. Now, I'll be talking a little bit about why we don't like async void methods once we get to exception handling. So generally a best practice is to say, oh, I want to return a task, even if I'm not getting something back. And then the other thing it's going to suggest is renaming this method to put an async at the end of it. Well, if I do this, it's going to break my application because I can't return a task to an event handler because it would say, hey, that doesn't match what I'm looking for anymore. So the easiest way is to just type in async yourself if you're inside an event handler. So just as a heads up as far as what that will do. The second one will, but it will still want to rename the method. And again, if the rename isn't put in the place where it's hooked up in the XAML in this case, then that would also basically unhook my event handler. Okay, now what do I have? Okay, well, this var for result says that this is a list of T, and then down at the bottom, T is a person. Oh, that's good, because that means this is a list of person. Great, let's call this people. Okay, now what? Well, I have a list of person. Let's just loop over this and see what happens. So for each person and people, person list box.items.add person. Okay, based on what I had to do up here, this really doesn't feel like enough code. But we're going to try it. So let's go ahead and just run this and see what happens. Okay, so we'll click on the fetch with await button, and we'll wait 3 seconds, and then, oh, there's data. Okay, that's cool. Is it asynchronous? Again, I'll do my little janky, hey, look at that. I can still interact with the UI. So it is asynchronous. Wow, I like that. That is really cool. Okay, now what happened with this whole marshaling back to the UI thing that we had to do specifically with task? Well, what happened is, again, the language designers were kind of looking at, okay, how is this await going to be used? Well, if we look at the code here, what we see is basically we have 4 lines of code. So I go line 35, line 36, line 37, and then line 38 a bunch of times, and then I'm done. Now, if I'm normally going through a method like this, I would not expect line 35 to run on a different thread than line 37. So the people who built this said, people are going to expect this to be on the same thread. So that from current synchronization context is the default when you're using await. And that's exactly what I need here. Now, it might not be. And so something that you hear often when people are talking about awaiting methods is that you should use this configure await false. This is a best practice. Use configure await false. Use configure await false. Use configure await false. You really should be using configure await false. Well, what does that do? It puts it back to the same way that task does it. So if we run the application at this point, then what we'll see is after our 3 seconds, we'll see that we get the same exception that we saw earlier. So this is the invalid operation exception, and it's saying, hey, you're trying to access the list box, a UI element from not the UI thread. So that's what configure await false is about. Now, when we're talking about, is this, why do people say this is a good idea? Well, if you're building library code, you probably don't care about what thread you're on, because the person calling your library, they might care about what thread they get back to when you're done. But generally, if you're building a library, you don't care. And so if you use configure await false, it is a little bit more performant. Now, when I say a little bit more performant, if you're going to be doing this a bazillion times, then you're going to see some benefit. If you do it twice, you probably will not notice. So if you're doing library code on a server and configure await false, and you have millions of requests, you might see a visible difference. I honestly don't know, because I haven't done any performance testing on this. But basically it's saying, if we don't use that, then it does that from current synchronization context. So there is some overhead where it says, you know what, I need to grab the context and hang on to it so that I can get back to it when I'm done. If you say configure await false, that process doesn't happen. It doesn't grab the current context. It doesn't worry about getting back to it. It's just like, okay, what's the easiest thing to do right now? Oh, you know what? I have this thread that I've been using. I'm going to keep using it. That's the easiest thing for me to do. So that's where configure await false comes in. So from a UI perspective, again, in this situation, it's not a good thing. In a library situation, it generally is, and that's why you hear people promoting this. In a web situation, it might be hit and miss. For example, if you're doing some more old school web development, where you're using things that are in the session, for example, the session is tied to a thread. So if you need session information, you kind of need to go back to where you were so you can read that session information. So that's just kind of a warning about that. Okay, so I've showed how we can kick off an asynchronous process, get the result, stick it into a list box with both task and with await. And I've been talking a really long time, really quickly. So I would like to pause for a second before I go on to the next thing. And let's see if there's any questions on what we've looked at so far. Anyone? Let's see. I managed to lose my chat window.
We had one question in the chat, but I think
Okay.
you addressed it already.
Oh, look at that. So we've seen result and configure await false. Yes, we've looked at both of those. And if you've got any follow-up on that question, I would be glad to talk some more about those, because those are things that people ask about all the time. Okay, well, I'll keep an eye on the chat window, and also feel free to barge in on your microphone if you'd like. I am going to move on and say, oh wait, actually before I move on, I was going to talk about exception handling, But before I talk about exception handling, I really need to talk about a UI issue that we have with our application. So let's run this application again. And we'll click on the fetch data with await button. And I'm going to click it 3 times. How about 4 times? Oh, look at that. I got 4 sets of data back. Huh, that's interesting. Does this do the same thing? Yep, it sure does. Okay, that's fun. Let's look at our await method, since this is a little bit more like normal coding, and see if we can figure out what's going on. It's like, okay, so my first instinct is, Jeremy, you're an idiot. You're not clearing the list box. But as we can see on line 35, we are in fact clearing the list box. And what's happening is the joy of asynchronous programming. So what's happening is every time I click the button, it goes clear, clear, clear. And then 3 seconds later, we get data, data, data. So that's what's happening here. Now, I have had some rather intense discussions about the appropriate place for clear list box in this method. It really needs to go after line 36. But then you don't clear it at the beginning. Oh, maybe before and after. Oh, wait. However you try to put in this clear list box, you will run into weirdness in the UI. And the bigger problem is, which data do we want the person to see? Well, I don't want them to get 3 or 4 sets of data back. I want them to get 1 set of data back. And I don't want to call, in this case, I'm calling a service. I don't want to make a service call 4 times if I'm only going to show you 1 set of data. So rather than dealing with this clear list box, I'm just going to deal with the UI. And I'm going to take the fetch data with await button and set its isEnabled property to false at the top of my method. And then set it to, oh, that's an equals, isn't it? Equals false. That would be better. And I'll set it to true down at the bottom. So rather than trying to figure out where am I supposed to clear the list box, I'm just going to make it so you can't click the button multiple times. Hey, look at that. It's disabled. I can't click it. When the data comes back, it re-enables. Don't overthink this, because my first tendency is to overthink this. Oh no, I have to figure out where to put clear list box. No, I need to fix my UI so that the user can't enter an invalid state. So these are the things I think about. Now, what happens if I get an exception somewhere in this block of code? Well, my button would just stay disabled. How would I deal with that normally? Well, in normal code that's not asynchronous, I would just set up a try finally block. So I'm going to do that. Okay, so I'll highlight this block of code, and then I love keyboard shortcuts in Visual Studio, so I'm going to use the keyboard shortcut Control-K, Control-S. And that's the shortcut for surround with snippet. And this has a set of code snippets that have the concept of a body to them. And in this case, I can type in try F, which represents a try finally block. I hit enter. It takes the block of code that I had highlighted it, wraps it in a try block, gives me a finally block, puts my cursor there so I can start typing. This is like lazy developer for the win scenario here. So I love that kind of stuff. And then I can just move the re-enabling the button into the finally block so that I can take care of that when it comes up. Okay, so there's a question of what's the best practice to handle multiple async functions? I will come back to that at the end. Is that okay? Well, it's gonna have to be okay because that's what I'll do. I'll get through the rest of this and then we can take a look at when you need to step outside the box, because what we're seeing with this await is that it gives me that 95%, right? Most of the time, here's what I want to do. Make an asynchronous call, get data back from it, keep going, right? That's what I want to do. And so using async await for that works brilliantly. Now, if I want to step outside of the box and say, okay, well, I need to await 3 methods. If I use await, it'll run those in sequence. If I want to run them in parallel, now I have to step outside of the await box and do something else. So, and that's something I love to play with too. I have another talk that I do about parallel programming, which is really cool. If I do say so myself. That's nice, isn't it? Okay, well, let's fix our task button as well. So at the top of this, we'll say we have a fetch with task button. We'll say is enabled to false. And then down at the bottom, we'll set it to true. Okay, and then we'll run our application. Oh, and click the button. Oh, it didn't disable. Oh, now I've got like 6 sets of data. Oh, why didn't that work? Again, we're dealing with asynchronous code here. So let me set a breakpoint here on line 21 and another one here on line 26. So let's click the button again and just kind of step through this code. So I step and I disable the button, then I clear the list box, then I kick off the getAsync method. And then notice this whole block with the continue with is highlighted. This is me setting up the continuation. This isn't the inside of the continuation running, it's me setting up the continuation. And then my code keeps running, so I hit this block that re-enables the button, and then I exit the method. So basically what's happening is I'm disabling the button, and then nearly immediately re-enabling it. And then if I hit run from here, then I'll end up inside after, again, the data returns. And then it just kind of walks through the inside of our Lambda expression here. So really what we need to do is not re-enable the button down here at the bottom of our event handler, but do it inside of the continuation. So after the data's come back and we've dealt with it, then that's where we want to re-enable the button. And then we'll see that this operates as we would expect. So click the button, now it's disabled, I can't click it again. When the data comes back, the button re-enables. Now, in this case, I could deal with, okay, what happens if we get an exception in this block of code? Well, the thing I'm going to talk about now is what happens if we get an exception in our asynchronous method. So I'm just going to leave this code the way it is for the time being. So let's jump back to our asynchronous method. And after our 3-second delay, I'm going to throw an exception. So we'll throw a new not implemented exception. And we'll say, Jeremy did not implement this. So go talk to him. We'll put blame right in the exception message. And now let's see what happens. And I'm going to start with task in this case. Okay, so now we'll click on our button, wait the 3 seconds, and then we'll see that we get an exception that pops up. And one thing to notice is that this is an aggregate exception. So even though I threw a not implemented exception, the exception I'm getting here is an aggregate. And we'll look at what that means in just a bit. Now, what's happening is you'll notice where this exception is pointing to is this task.result property. Now, when you're talking about multi-threading and exceptions, things are pretty fun. And I use fun in the worst connotation of the word. Because generally what happens is if we have an exception, or I'll put it this way, an exception will stay on its own thread unless we go looking for it. And I can prove that right here, because let's comment out the block of code that checks the result. Okay, so I'm not checking the result, I'm not populating the list box. Inside the continuation, I'm just going to re-enable the button. Now, if I run this and then click the button, wait the 3 seconds, then what we'll see is that the button re-enables. So we don't actually see the exception that happened in that asynchronous method because we're not looking for it. And that's the default of how threading works. Now, the reason we are seeing it in this case is because we're trying to access the result property on a faulted task. So when a task gets an exception, it goes into what's known as the faulted state. And when a task is in the faulted state, result is not valid. It's not null, it's not empty. You're not even allowed to access it. So in this case, if you try to access the result property on a faulted task, it's going to show you the exception that happened. So this isn't the best way for finding exceptions, but you can rely on it actually happening. Okay, well, I kind of don't want to look at the result property unless this finished successfully. So the good thing about this is that task has several properties that are useful in this scenario. So if I look at task.is, we'll see we have an is completed, is canceled, is completed successfully, and is faulted. So these tell us what state our task is in. So what I can say is, oh, well, if it's faulted, then go ahead and handle the exception. And then it would be really easy to say else here. So if it's faulted, do this, else do the happy path. But the problem is that it also might be canceled. So we might have to say task is canceled, then handle cancellation. And then we'll say if task.is completed, then we'll do the happy path. Oop, happy path. And then re-enabling the button will be outside of all of this. Okay, so regardless of whether it's faulted, canceled, or completed, we will have our re-enabling outside of all of this. Okay, well, let's go ahead and do something that you should never, ever, ever, ever do to your users, which is show them a raw exception. So just for demonstration purposes only, I'm going to do a message box.show, and we'll say error, error, error. And then we'll put in the exception, the type of the exception. Okay, how do we get to that? Well, task has an exception property on it, which is populated if the task is in a faulted state. So we can actually look at that. And in this case, I'll do a get type on this so we can get the type of the exception out. Now, again, I will say don't do this to your users because raw exception messages are not good for users. But what I'm showing you is how to get to the exception so that you can stick them into your logging process or however you deal with exceptions. So demonstration purposes only. Now, one thing that you'll notice is that I've got a green squiggly under task.exception. And that's because I have the non-nullable reference types turned on in my project. So this is something that we got in C#8. And down here on line 12, you can see I've enabled nullable. It's called nullable reference types, which is confusing because reference types are normally nullable. If you enable nullable reference types, then reference types are not nullable unless you say they are. So terminology is really confusing. But basically it's saying, hey, you know what? This exception property might be null. And if you access something that's null, that's really bad. Now, what's good about this nullable reference types, I'll say process, is that if I actually do a check to say exception is not null here inside the if block, those green squigglies go away because it's smart enough to say, oh, well, you're checking to see if it's null. So it's obviously not null here. So I'm going to let that go. Unfortunately, it's not smart enough to know that if a task is faulted, then the exception is not null. So the compiler can't really help me out here. So what I can use is I can use a bang operator after exception. And basically, this is the I know what I'm doing operator. So I'm getting a warning that says, hey, this exception might be null and you're accessing it. And I'm saying, you know what? I know what I'm doing. I know it's not null here. So that's what that operator is for. I kind of stick things like that into my demos just so that we can see so many language features get added to C#. So I try to make them a little bit useful. So here's our pop-up, and it says error, 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 and I can see it's an aggregate exception. And again, we'll look at what that means in just a minute. And I say, okay, and oh, it's trying to access my result property. So the next question I have is, why am I in this block of code? Well, it's because is completed does not mean completed successfully. It just means no longer running. Now, the reason I'm showing you this specifically is because you might have noticed when I was looking at the options for task, there is an is completed successfully, which is very obviously what I want here. Well, if you're doing .NET Core, you're golden, because is completed successfully has been in .NET Core since .NET Core 1.0. It is not in any version of .NET Framework. So when I started doing this with .NET Framework, I tried to use is completed, and it's like, okay, that doesn't mean completed successfully. It just means no longer running. So not useful in this scenario. Now, if you are in the .NET Framework world, you do have options, because task also has a status property. And the status property is an enum of task status, and it actually has a ran to completion option. And there is also a faulted and a created. There's a canceled in here somewhere as well. So there's canceled. So it has all of the states that a task can be in. So if you do want completed successfully and you're in the .NET Framework world, check the task status. Now, I'm kind of upset that they didn't take the is completed successfully and backport it to .NET Framework, because to me, that's a no-brainer, because that's a calculated property checking the status. So there might be performance issues. I don't know why they didn't, but it kind of upsets me that it's not in .NET Framework. It kind of upsets me that it wasn't in .NET Framework to begin with. But that's as far as I'm going to go with there. Okay, so let's go back to this aggregate exception. Okay, what is an aggregate exception? Well, I talked about how task is very powerful, and you can have a task that kicks off child tasks, and those child tasks all run at the same time. And the question is, what happens if I have 5 tasks that are running at the same time, 2 of them complete successfully, and 3 of them get exceptions? What exception should I show you? Should I show you the first one that happens? First is a very dangerous word when you're talking about concurrent or parallel programming, because first on my machine is going to be different than first on your machine, depending on the number of cores and everything else that's going on the machine at the time. So what the language designers did with task is they said, oh, well, we're going to wrap all of those exceptions up and give them to you as one thing that's known as an aggregate exception, which is actually a tree structure. Okay, great. How do we get to the real exception? Okay, well, I could say task.exception.innerExceptions, right? That's kind of a standard thing that we all do. Unfortunately, inner exceptions is also potentially aggregate exceptions. And so depending on what your situation is, it could be aggregate exceptions all the way down. Yeah, now what? Because I don't know the stuff I'm calling, maybe it is kicking off 7 child tasks that run in parallel. I don't know. Do I need to be worried about this? And so my initial tendency is like, oh, well, I need to come up with some kind of a tree parser for this so that I can get down to the real exceptions, and no matter what it gives me, I can figure it out. Now, before you build your own tree parser, I'm going to show you a magical method on aggregate exception. And the magical method is known as flatten. And what it will do is it will take the tree structure and go and make a single level of inner exceptions. So if you look at inner exceptions on a flattened aggregate exception, those are all going to be real exceptions. You're not going to get more aggregate exceptions. Don't tell me how long. I'm not going to tell you how long it took me to figure this out, but if you need tree parsing code, I might have it somewhere. Okay, so now I'm going to do something you really should not do to your users, and that is I'm going to for each over the inner exceptions in this. So for each exception in the flattened inner exceptions, and we'll kind of go like that, then we'll say ex.getType. And then you'll notice I have the same thing here where it's like, okay, yes, I know what I'm doing. I know that's not null. And then, you know what, let's go ahead and add the message as well. ex.message. Okay. Now, the bad thing about for eaching through this is potentially I could have 5 or 6 exceptions, and so my users would get pop-ups for each one of these messages. Don't do this to your user, please don't. But I do want to show that you can get this flattened structure, you can iterate through it, put it into your logging structure so that you can handle them and figure out what you need to do to your application to you know, protect against these particular issues that come up. So in this case, I get the real exception. Look, it says not implemented exception. Jeremy did not implement this. So this is how I get to the real exception. That was a long way to get there. Now, one thing I will say is that Visual Studio is getting a lot better because one thing to notice, I'm going to put this back to is completed so that we can see the exception that pops up with task.result. So we'll get our pop-up, okay. And this box has actually changed, I will say, in the not too distant past. So you'll notice that we have this aggregate exception, and then inside, there is an inner exception that's noted here. This says not implemented exception with the real message, Jeremy did not implement this. So showing this inner exception is actually something that's fairly new in Visual Studio. So the tooling keeps getting better. That's one thing I really like about Visual Studio is they do keep making things better. Although sometimes it's hard to keep up with what's going on where. Okay, so that's kind of a lot that we had to go through to deal with the exception on the task. Let's see what happens with await. And for this, before I do any exception handling, we'll just click the button to see what happens. Okay, so what happens is it stops on the get async method, which is exactly where we would expect it to stop in normal code, right? I'll say synchronous code, non-asynchronous code. And then something that's really interesting is if you look at the exception, it's showing the not implemented exception. Wow, that makes life so much easier. So when you're using await, you don't have to deal with the aggregate exception. And that's because generally, again, when we're doing this await, it's often something that's just doing one thing asynchronously. You don't get the tree structure of exceptions back. So it says, oh, you know what? If I find a structure that has one exception in it, I'm going to unroll it for you. So that's really cool. And that's something, again, that's built into how await works. So the defaults for await are really good. Okay, so how do we deal with this? Exactly the same way we deal with any other exception. So I'm already in a try block, so I can add a catch block just like that. And that'll be the message that we have here because I'm too lazy to retype all of that. And we just treat this like any other normal code that we would use. So again, if you don't need to step, oh, I clicked the wrong button there. If you stay inside of the await box, meaning here's the little piece I need to run, using await is awesome. Because again, here I get the real exception, not implemented exception. I don't have to unwrap it. It's just there. I deal with it with a try catch finally block. And so you can see my finally ran and the button re-enabled. So everything just kind of happens the way I would expect it to. So definitely await is the way to go if it fits into your world. Okay, so I have one more thing to show you. And that is dealing with cancellation. And the reason I show this is because I ran into some interesting issues the first time I tried this. A lot of times I'm talking to people who are doing mostly web development. And so Cancellation doesn't really make sense in that world, but in the Xamarin world, it might, depending on what you're doing. So yeah, this will hopefully be useful. So what I'm going to do is I'm going to add a cancellation token parameter to my asynchronous method. So we'll say I can pass in a cancellation token, and we'll call it cancel token. And I'm going to new up a new cancellation token. Now, the reason I'm doing this is so that I can have a default cancellation token. So my current methods don't pass in a token, which means we don't care about cancellation. So I want them to keep working. I don't want to force them to pass something in. And then if I just create a cancellation token with the constructor with no parameters, it will create a token that's in the not cancellation requested state. One fun thing when we're talking about cancellation is basically a flag. So a cancellation token, basically there's a little, your token just like raises its hand and says, so if you care, someone would like to cancel this operation. And it's really up to the calling code or the code inside of this method to figure out how it's going to use that information. Sometimes we can't do anything about it. If I've kicked off a request to a web server to get some data back, I really can't cancel that request because it's gone. But I can stop waiting for it. I can possibly put together a default payload to get back to my users if that's the scenario I want. So there's things that I can do even if I can't immediately cancel a process. Okay, so after this task.delay, we'll check the cancellation token. Now it's really tempting to say, okay, well, cancellation token has this is cancellation requested property on it, and this is a true false value. So I could look at this and say, oh, well, if somebody requests cancellation, then I can deal with it. The problem is I don't know exactly how to deal with this because I haven't dug into task that deeply. I mean, I know I need to set the is canceled property to true. I know I need to set the is faulted property to false. I know I need to set the is completed successfully property to false. I need to set the is completed property to true. And I need to set the task status to canceled. Well, that's 5 things at least that I would have to do. Well, don't do any of that. There's a method on the cancellation token that you should use instead. And a lot of people don't like to use this method because it's called throw if cancellation requested. The reason people don't like to use this method is because it has the word throw in it. And throw implies that there's an exception being thrown. And we are taught as a good practice to not use exceptions for flow control. So I shouldn't use an exception for flow control to break out of a loop, for example. So I shouldn't throw an exception just to catch it because the loop is done. And the reason we're given that advice is because exceptions are expensive computationally. Whenever we throw an exception, it has to unwind the call stack. It has to collect all the information. It has to start bubbling up that call stack to see if there's an exception handler somewhere. There's a lot of things that happen when you throw an exception. And because of that, that's why we're told, don't use exceptions for flow control. Use, a better if statement potentially, or a break in a for loop. And so we want to avoid that when we can because exceptions are expensive. Well, in this case, I'm going to say, let it go. Because if we call this method throw if cancellation is requested, the infrastructure takes care of everything for us. So it makes sure that all of the properties are set appropriately. It makes sure that the exception property is populated appropriately. It takes care of all of that. So use this method if you would like to stop your method. And again, this is a flag. So in this case, I put it after the 3-second delay because that'll give me some time to click the button later on when we hook it up to the UI. But in the meantime, if, for example, I don't click the button until, we kick off the call to the web server, well, we're not checking for cancellation anywhere else. So that flag will basically be ignored after line 28. So if we haven't set it by line 28, we're not able to cancel this method. Again, it's just a flag. Now we could check the cancellation token in multiple locations on this method if we wanted to, but I'm not going to do that today. So again, it's just a flag. It's not an abort. It's not a stop. It's not a halt. It's just a request. Okay, so let's use this request. So let's start with our task button. And up here with the get reader async, again, if we look at this, I have a cancellation token parameter that has a default value, so I don't have to fill it in if I don't want to. But let's fill it in with a hard-coded token just to see if we can get things working. So we'll do a new cancellation token, and I'll pass in true to the constructor. And so what this does is it creates a cancellation token that is in the cancellation requested state. So it's saying, hey, yes, I would like to cancel. It's created that way. That's what it always says. So let's go ahead and run this and see what happens. Okay, so we click on our button, we wait our 3 seconds, and then our button re-enables, nothing else happens. And that is exactly what we expect, because inside our is canceled block, we have a comment that says deal with cancellation here. And then again, down on line 43, our re-enabling the button is outside of all of these. And so in this case, we can just do a message box and we'll just say canceled, like that. Now, I don't like to silently cancel, especially if we're in a situation where a user presses a button, or even if there's a timeout, because we can actually use cancellations for timeouts in certain scenarios. So I do want to give some visual clue to the user, probably not a message box because those are the most annoying things, but maybe a toast message. Are those still cool? I don't know. Or some other little thing that pops up at the top that says, hey, this was canceled, and it goes away after a second. So something to the user to let them know, hey, stop waiting for data because it ain't coming. So we could see that that was pretty straightforward to deal with. We already kind of had our if-else statements set up. Let's go down to our await method and take a look at this. Okay, so again, we'll just hard code a cancellation token, set it to true, cancellation requested. And let's just run this and see what happens before we do anything else. Okay, so again, we'll click our button, we'll wait our 3 seconds, and then we'll see we get a pop-up. And this is our exception message pop-up. That's kind of cool. Okay, why did this happen? Well, remember that throw of cancellation requested? It actually throws an exception. And that's good, because let's think about where we are in our code, okay? So we're awaiting this get async method. When we were dealing with task directly, we could check the is canceled property, or we could check the canceled status on the task itself. Where would we do that in this code? There's no task. The task is completely hidden when we're using await. So again, what the people who put this together said is, hey, you know what? Let's incorporate this into the exception handling mechanism that's already in place. It's familiar to the people that are writing this type of code. And we'll throw an operation canceled exception, which is a special exception, which means I can catch it separately. So I can catch an operation canceled exception and deal with it differently than a regular error message. So in here, we'll just say canceled, exclamation point, and I'll still show the exception type because it's kind of interesting. So what this means is that we can use our standard try-catch infrastructure that we already have in order to deal with cancellation as well. So now we click on the button, wait the 3 seconds, we'll get a pop-up message, but now it's a different pop-up that is our cancellation pop-up. So that's why you should let that whole thing about throwing an exception go in this scenario, because it's designed to work really well by throwing an exception. Okay, but a hard-coded cancellation token doesn't do as much good, especially when I have a button on the screen that I want to hook up. So I have an empty button click event handler. And so I'll try the most obvious piece of code I can think of, which is I'll create a class level field, which is a cancellation token. We'll call it cancel token, and we'll new up a cancellation token. And again, when we new it up like this, it's in the not cancellation requested state. And then I can pass that token into my various methods. And then down here, when I click on the cancel button, I can take that cancel token and set its canceled property to true. No, okay. I can call cancel. I can call stop. I can call halt. I can call please stop. So it turns out if you create a cancellation token yourself, you can pick which state you want it to be in when you create it, but you can't change it later. That doesn't sound very useful, does it? Now you might say, oh, look, there's this is cancellation requested property. Let's set that. Nope, if we look at it, that's a read-only property. You can't set it. Okay, I won't tell you how long it took me to figure this out, but I would recommend reading the documentation if you ever have to deal with this, because we don't want to manually create a cancellation token. This is not the object we want in this case. There's another object we can use, which is a cancellation token source. Now, a cancellation token source is an object that's responsible for managing a cancellation token. So if we go back down to our cancel button method, we can look at our token source's properties and see that it has a token property on it. Okay, so this is a token property that we can pass to our get async method. So that's great. Even better, it has a cancel method. Oh, if I can type. Come on. It has a cancel method. Yay, I like that. It also has a cancel after method. And this lets you put in either a number of milliseconds or a time span to say, hey, once this time passes, go ahead and cancel this. So we'll just set this cancel token to true. I know some people have used this for timeouts. I still kind of have a little bit of trouble using it as a timeout because I think cancellation and timeouts are two separate things, but if a timeout expires, you probably want to say, I don't care about this anymore, or I can't keep waiting, so you might want to cancel it. So it kind of makes sense as a timeout. Or you can just pass a random value to it and make your users wonder what's going on. But we'll just use the cancel method in this case. Okay, so I have the cancel method. Let's go to our await button and use this. Okay, so instead of having the hard-coded cancellation token in the get async method, we'll take our token source's token property. Okay, that's much better. Now there is one more thing that we need to do, and that is at the top of this method, I need to create a new cancellation token source. Now, the reason I need to create a new cancellation token source is because this is the only way to get a fresh token. Cancellation on a token is a one-way operation. So if I have a cancellation token source and I say, hey, go ahead and cancel, that's a one-way operation that says cancellation is now requested, there's no going back. And that makes a lot of sense if you think about it, because if, let's say I passed this token around to 5 or 6 different operations, because I have one big button for this workflow that I'm doing. Well, if I said, okay, go ahead and cancel, and then these methods start canceling, and then I say, oh, wait, no, don't cancel, and then these methods keep going, you're gonna end up with a mess. So cancellation is a one-way operation. You can cancel, you cannot uncancel. So to get a fresh token, you need a fresh token source. So that's why I'm instantiating this here. And now if we run this, we should have a working button. Okay. I'm just going to click the button and wait for the happy path to go by. Make sure I didn't break that. Okay, it's good the happy path works. Now let's go ahead and click the cancel button. Now I do still need to wait the 3 seconds because again, we're checking the cancellation token after the task.delay. but we can see we got our canceled operation here. That's great. I like that. Okay, let's do the same thing for our fetch with task. And this will be basically exactly the same. So we will pass in the token sources token property and create a new instance at the top of this method. And when we do that, click on the task button. And again, we'll wait for the happy path. And then we'll click on the button, wait the 3 seconds, and we got our canceled. That's good. Okay, generally the next question I get is, do we have to wait those 3 seconds? The answer is absolutely not. Because a lot of the methods that are built into the libraries that we use have overloads that take cancellation tokens. So the task.delay method takes an overload that takes a cancellation token. So I can pass it to that method. The getAsync method that our HTTP client calls has an overload that takes a cancellation token. So we can use this cancellation token in various methods. So in this case, we won't have to wait for that delay to finish. It'll actually cancel the delay. So this is something that's actually pretty neat. So we'll click on the button, and then I click cancel. The pop-up comes up right away. Click on the button, click cancel. The message comes up right away. So and then just out of curiosity, if you are looking at the exception that comes back with a wait, the message is different. So the message before, I don't remember, I think it says like an operation was canceled. In this case, it says a task was canceled because that task.delay, a separate thing was canceled. Whereas if we called the throw if cancellation requested method, then that gave us a different message. It's still the same exception type, so that's just a curiosity. You don't have to worry about having to catch something different, but you would be able to see it there. And these exceptions, again, they're full exceptions, so they have the stack trace. You can see where they came from, and all of the things that are going along with that. Okay, so I need to stop talking a little bit again. So I'm going to pause for questions. Nobody's interrupted me. I might have been talking too quickly and not leaving space for people to interrupt me. So if that's the case, I apologize. But keeping an eye on the chat, it doesn't look like people have been pestering me there either. So any questions at this point?
I've got a couple. I think something that comes up a lot is the need to call an async method from the constructor. And is there a good way to do that? Should you just avoid that at all costs? What's your thought?
So I would say avoid that as much as you can. I don't know if there's actually a good way of doing it. And that's generally because we want constructors to run fast and not fail. That's really the goal of any constructor. So it's great if it's like, well, I need to initialize a couple fields or make sure something's not null or, put in some default values. But once I start saying, oh, I need to go get some data in my constructor, that's kind of where we fall into the danger world, because we don't want that happening when we call new on something. So generally the best advice, if you have something like that, and we don't always have control, is to create a factory method or something that can be called as initialization code later on. Those aren't great either. But for example, in the, I will just open up the constructor on this main window, right? This has an initialize component. And so that does all of the constructor stuff, but you can also hook up an event handler that says, hey, when this is done initializing, run my code. And that runs out, the event gets raised inside the constructor, but then anything that follows on with that runs outside of the constructor. And so that way you're not blocking what's going on, if that made sense. Okay. So, and actually it's been a while since I've done this. This dot, I know there's I think it's an on. It's been way too long since I've done this. On render. Okay, you probably don't want me doing this right now. Wow, there's a lot of things going on here. I want to say on initialized. Hey, look, I found it. So there's actually an on initialized. This is an event. Yeah, there you go. So you can hook up an event handler to this so that the constructor actually exits, but then whatever is in this on initialized event handler will fire after the creation happens. So you know that in this case, your form is there and the XAML has already been processed in this case. So then if you need to go in and make programmatic modifications to the form or add things to it, you can do that in this event. Now, obviously, that causes issues a little further down because you're like, well, how do I know when it's really ready for me to use? And that's something that's a little more difficult to answer. So unfortunately, I don't have a great answer to that. Async constructors, I know that comes up from time to time in like the language design discussions. And usually the response that comes back from the language team is, yeah, yeah, we don't want to do that. And again, these are people that know why in a much better way than I do. So yeah, async, I would try to get it out of your constructor. If you can't get it out of your constructor, then basically you could kind of treat this on initialized if you use task manually. So if I use task manually, there's no async modifier, so I don't have to mark it as async. And there really isn't a return type on a constructor, well, the object itself. So you could actually hook up a continuation inside of your constructor, and that continuation would run when that asynchronous method is done. So that's not a great solution, but it's a possible solution. And it would be very similar to hooking up this on initialized event that we have in a form. Does that make sense?
Yeah. No, that's great. Thanks. And then the other thing I had a question on, which you touched on earlier, was async void. And
Yes.
what's
Okay,
the
actually,
best practice on that if you have a method that's async but doesn't have a return?
yes. So now that we've seen, let me go back to our await. Actually, either one of these. Okay, so when we have an async void, what that means is there's no task coming back from the method. And what that means is we cannot await the method. So if we don't have a task and we don't have an await, it's truly a fire and forget. So if you have an async void method, there's no way to know if it completed at all, period. There's no way to know if you got an exception. You basically lose complete visibility to it. So if you do have a true fire and forget scenario, async void makes sense. And so like if I have an operation where it's like, I've got a data stream coming in, and if not all of the records make it to the database, that's okay, because maybe I'm doing diagnostics on a piece of equipment that I have, and it sends out 100,000 records every second. Just, here's the status of all my different things as my machine is running. It's probably not important that I catch all of those records. It might be, but I probably want to make sure I catch a vast majority of them. So that might be a true fire and forget scenario. Now, if something happens and I'm no longer connected to where I'm storing the data, well, I'm not getting anything in my database, and I have no way to see that. So hopefully you might want some monitoring on the other side to make sure you're still getting stuff. But async void is a true fire and forget. And really kind of so there's kind of three really big names in the async world. One of the names that you'll want is Stephen Cleary. And just let me just bring my website over. So I'll show you how to get there. So here's my website. And again, if you click on presentations, you can see here's our group right here. If you click on presentations, oh, I'm sorry. I'm doing a talk tomorrow night, so I've already updated my website. So here we are, Houston Xamarin Users Group. And this will always be on this list. It will scroll down. But if you click on it, it will take you to the resources. And part of these resources, and you can see I've got a lot of stuff, a lot of blog articles. There's a YouTube series, and there's a list of async experts down here. So Stephen Cleary is one of the, I'll say he has several books that are published on async topics. I think it's called the .NET Concurrency Cookbook. And I think there's more than one that he has. But he's really good as I'm a developer and here's the things I need to do with async. So he's really good at that. Stephen Tobe, he used to work for Microsoft. I don't believe he does anymore, but he knows more the internals of how all this stuff works. And then Lucian Wischik, who unfortunately no longer works at Microsoft, he was just the nicest person you would ever meet. He's the one who actually wrote this stuff. And I'm still pretty sure he's the only one on the planet that actually understands what's going on underneath. So Lucian has some great parallel versus concurrent, I'll say presentations with like slides and video and demonstrations that show, okay, if you have an IO bound operation, meaning, you know, maybe file system, maybe waiting for a service, you want to do concurrency this way. If you have a CPU bound operation, you want to do concurrency this way. And if you mix those up, you actually make your performance worse. So he has a lot of good stuff on that. Anyway, back to Stephen Cleary, who has written a lot of great stuff. I actually went to a talk that he did on async, and he had a slide that said, every time you use async void, Rory dies. So, okay, I found the Doctor Who fan. So that was his slide. So, and Stephen Cleary has a lot of great articles about doing sync over async or async over sync, which is where I have it kind of like the constructor, right? So my constructor can't be asynchronous, but how do I call asynchronous code inside that? And that's known as sync over async. So there's async on the inside and I'm turning it into something not async. And he talks about basically the issues that you will need to deal with in those scenarios. So he's a great resource. So if he says every time you use async void, Rory dies, I'm gonna believe that. Again, in the UI world, event handlers are definitely an exception because they have to return void, otherwise they don't work. But otherwise, yeah, async void. And even, so you can use async, you can do an async main on like a console application or actually any application. But if you do async main, you have to change the return type to task. Otherwise, it won't compile. So even if you do an async main, it'll say, oh, main has to return a task. Otherwise, I can't do this. So that's kind of the story with async void. If I had an async void method, I would have nothing to await because you can't get data back out of an async void method. And even if it's, I don't need data back, I just need to do something asynchronously, like write code to a log, or write a message to a log, I would lose visibility on whether it completed successfully. So that's why async void is considered something to avoid when you can.
All right, great. Thanks, man. Anyone else have a question for Jeremy?
Well, I can,
or
and I can also go back to the, what if we need to run multiple async things at the same time?
So either unmute yourself or type something in the chat. Let us know.
Well, I would like to hear about that one,
Okay.
about the multiple.
So when we're using await, we really are looking at a one at a time operation. Meaning, let's say I called this method 3 times. Let's say I was calling 3 different services, right? what happens is all three of these methods will run in sequence. So if I run this, instead of waiting for, and these values are getting discarded, I'm not using these additional ones, but because these are running, that's the wrong button. Good job, Jeremy. Just wasted 3 seconds of your life. So instead of waiting 3 seconds, I'll end up waiting 9 seconds because each one of these methods takes 3 seconds to complete. So a lot of, I won't say a lot of times, there are times where, let's say I need to get data from 3 different sources. Maybe I need to call 3 services, aggregate it into a single object. In that situation, a wait will not work. But what we can do is we can step outside and use task more directly. So there's a couple different ways of handling this. There is a, yeah, let's not do that. So what we can do is, let's see. Oh, yeah, okay. We'll just do this. We'll show the difference. Okay, so we'll create 2 tasks or 3 tasks. Now, in this case, the continuation is only set up with one of these tasks. All 3, you know what? Let's copy this. I don't know if this is the best thing to do. Yeah. Okay, so this is going to be a little confusing. What I'm doing is I'm setting up 2 different continuations. So this first one, I'm setting up a continuation that will populate the list box, our standard things. And then let's do 1 instead of 2 to be less confusing. And so now I have a continuation on this second tab. You know what? Let's do all 3, just for the wow factor, right? Okay. Okay. So now I set up continuations on all 3 of these. Now it does mean I'm going to get 3 sets of results back in my list box, which, you know, we'll pretend that that's okay. And so now when I click the button, I'm only still going to wait those 3 seconds. So I got all of that data back. Let me do it again, maximized. So I'm waiting 3 seconds. I'm not waiting 9 seconds because all 3 of those tasks are actually running at the same time. So that's pretty cool. But you might say, well, what if I don't want 3 separate continuations? What if I just want 1? Okay, well, what we can do is, let me just get rid of these extra ones again. Ooh, don't want to pollute the code too much. Okay, so now I have a single continuation, which is currently on our person.task, but I'm creating all 3 of these tasks. Well, what I can do is I can set up another call. So task has a when all method that takes an array of task or an IEnumerable of task. So what this means is that, let's just create, just so it's apparent, let's create a list of task and tasks, new list of task. And then we'll pass in person task 1 and person task 2. Okay, so I've just created a little list of all of those tasks. And I can say, when all of these are complete, continue with blah, blah, blah. So in fact, yeah, I could do it here. Oh, wait. The easiest thing is continuation. Not to actually dot that because things get interesting here. Because what this is this is a single task. Sorry, I have beagles. It's amazing they lasted this long. And that's what doors are for. So what this does is it gives us a single task back that now we can run the continuation on this. Now, the problem is that this continuation doesn't have the data that's coming back from these other tasks. So aggregating the data gets a little interesting, but this is kind of the basic thing that you can do where you say, okay, I'm going to create separate tasks and kick these all off at the same time. The task scheduler will figure out what thread resources it has available and kick them off as close together as possible. And then you can say, when these are all done, I would like you to do something else. Getting the data back is a little more interesting when you start talking about running code in parallel. A lot of times more functional style operations are easier to work with. I do have some samples. So let's see if I have additional. I'm pretty sure I put that on here. Oh, yeah, here we go. So I have another complete talk, which is about parallel programming in C#. And this is really kind of the code you'd want to look at for that, because I have several operations. One uses a parallel for, so there's actually a for loop that's built in where you can, let's see, console, actually it's in the library, I think. In the grid. Yes, so this shows using a parallel for, and actually several different variations of it since it's a multi-level grid. And then kind of the one that I think is pretty interesting is I have an application that does, I'll say discount machine learning that runs code in parallel. And the way that I do this is I end up creating a task for each item. Let's see. Yeah. Okay. So in this case, I have a for each loop because I want to process, in this case, let's say 400 images. So I have, I'll loop over each one of these images and I'll create a new task using task.run. And this is a more explicit way of creating a task if I don't have a method that returns me a task. So this will create a task and then I can add it to my task list. And I can have a continuation for the task that I just created. So once that one task is done, it will keep going by doing something else. And then I can have, again, this when all. And if I await the when all, then this code that records the end time will not run until after all of the tasks are complete. So I know that's probably not enough information to be very useful, but it kind of gives you a general idea of if you need to start doing parallel, you step away from await and you start using task more directly. Does that make sense?
Yeah, that was perfect. I've done something similar before. I would have just needed a refresher. I appreciate it.
Yeah, glad to help.
All right, anybody else? Jorge just posted something in the chat.
So continue with is expensive to do. Would it be better to use two awaits or not really? So if you're doing, it all basically compiles down to the same thing. So there are some other things that you can do with continuations, which I have some articles on. So let me just put this code back. Because like I mentioned, this continue with has a lot of overloads. So some of the overloads include task continuation options. And the task continuation options, let's see. Can you do it down here easily? So the task continuation options, for example, here in this little pop-up, it says you can say only on canceled. So you can actually set up separate continuations that only run at certain times. So I could have a continuation that only runs if the task is canceled. I can have a separate continuation that only runs if the task is faulted. I can have another continuation that only runs if it completes successfully. So these are actually separate methods that won't run unless a certain state is hit. And there really isn't an overhead per se with that. It's basically just setting up a scenario, because really what happens if you dig into it is the compiler builds a state machine. And I can't go into the details of the state machine because I don't know them. But the compiler actually builds a state machine as far as like, okay, it's in this state, this state, this state, what is going to happen next? And so as far as overhead, I really don't think there's a whole lot of difference between await and task if you're and a continue with, if you're just kind of doing the basic stuff, because it kind of all turns into the same thing underneath. Once you get, again, once you get more detailed as far as, well, there's a lot of options or branches or multiple tasks running at the same time, that obviously gets a lot more complicated, and there's things you can't even do with await. So, but it is very common if you have things that need to run in sequence to just say, okay, I need to await this. I need to await getting all of the prices from the catalog. And then I need to await getting a total from the order that needs all of the prices from the catalog. And then I need to await this other process that might be doing something else. So these actually need to run in sequence. They cannot run at the same time. So it's very common to have multiple awaits inside of a method. In fact, this person reader does, there's an await on the get async for the client, and this is actually getting the data from the web service. And then there's actually an await on reading the strings from the response. So it's very common to have multiple awaits inside a single method if they need to run in sequence.
All right.
Anything else?
I think that might be it. Thanks, everyone. Thank you, Jeremy. That was really awesome.
Yeah, and I really appreciate you letting me come and speak. This is stuff I love to talk about, so I appreciate the opportunity.
I can't wait to open up my Visual Studio tomorrow and realize all the things I'm doing wrong. All right, I'll when I figure out how to get the video from Zoom, I'll post that and share the link with everyone. And when we decide what we're going to do next month, I will post that on Meetup. In the meantime, everyone have a great rest of your summer and stay safe. Thanks again, Jeremy.
Yeah, thank you.
Thanks, Jason.
All right, good night.